Class we study the acceleration. Okay, and formula of acceleration. What is the formula of acceleration? The formula of acceleration a equal to v minus u upon t. So what is the v? V is the final velocity. Yes, and u is the initial velocity and t is the time. Okay, so the difference between final velocity and initial velocity upon time is nothing but acceleration. So what is the unit of acceleration? Can you think about that? SI, unit of acceleration. So how to calculate a unit? Yes, unit can be calculated. Yes, so what is the SI unit of acceleration? Yes, so change in velocity. Change in velocity calculated in means distance, and distance is unit is SI unit is meter is correct, and time is a second. Yes, correct. So SI unit is the meter per second square. Okay, the SI unit of acceleration is the meter per second square is the SI unit. Okay, so now in today we will study positive, negative and zero acceleration. Is the name indicate that only what is the positive acceleration, what is the negative acceleration, is it? So positive means they have the positive direction, negative means they have the opposite direction, and zero means there is a no acceleration. Is it correct? Yes. There is yes. So an object have the positive, negative acceleration. When the velocity on object increases, the acceleration is positive. What is velocity of the object is increases? The velocity of object is increases, that's called positive acceleration. The velocity of increases is the positive operation, and the velocity of acceleration is the direction of velocity. In case acceleration is the direction of velocity, is it okay? The when the velocity of object decrease then negative acceleration, is it? The negative acceleration also is called the velocity of acceleration is decreases is also called deceleration. Okay, it's also called deceleration. Okay, they maybe ask a question what is deceleration, or define deceleration, or calculate deceleration, like that question. Okay, so you must remember that deceleration is nothing but a negative acceleration. Okay, if a direction is opposite to the direction of velocity, is the deceleration. If the velocity of an object does not change with time, it's a zero acceleration. Means does not change with time is a zero acceleration. So I understood that positive acceleration, negative acceleration and zero acceleration. All three concepts are clear here? Yes. So now next topic is that time distance graph. Distance type graph for what? Uniform motion. Uniform motion means equal interval of time and equal distance will be covered there. So let's see that. So yes, let's see what will be here. Okay, so yes, here is a time distance time graph for uniform motion. So here the in this the following table show the distance covered by car in fixed time interval. Draw a graph of the distance against time taken. Okay, along x-axis time is the x-axis and distance is the y-axis. Okay, so let's try to draw. So first of all, here is the given what, here is the time. Okay, here is the time given, here is the time given, the direction, and just wait. This is the time given in x direction. This time given in x direction and distance given in y direction. Okay, fine. So here is the time is 0. So here is the 0. Suppose is a point. Suppose this is the A point. Okay, according to A, B, C, D, E, F, G. Last one is the H point. Okay. Yes. Okay. So suppose here is a given A point is a 0 0. Is it correct? Both is a 0 0. Also here is the origin form there. Okay. So time is 0 and also distance will be covered in the 0. So after 10 seconds, distance will be covered 15 minutes. So 15 minutes means here the 10 and here from the 15. So here the 10, here for the 15 means, sorry, here is the wrong, just wait. Okay, now so here is a 10 and here from 15, is it? So distance cover, time is 10 second and meters is a 15 meters. So here is a 10 and here from 15, so 15 is approximately here. So here will be point cover here. There will be point here approximately. Okay, here is a point for 15 approximately. Okay, in calculation is the drop difficulty. Next is that time is 20 seconds and distance will be what, 30 meter. Okay, so 30 meter is here the 20 and here is approximately 30 meters. It means here is the approximately here, is it correct? Is 40 above and here is a 40 30 is correct. After that time is a 30 and distance will be 45. So time is here 30, time is from here 30 and here is a 45. 45 means above 40 and below 50 is there here, sorry. Okay, fine. So okay, fine. So here is the distance. After that the next is the 40, 40 time and 60 is the distance. So 40, here is the 60, is it? After that 50 75, 50 75, just wait, that will be difficult to me. Okay, fine. So that will be difficult. What will be 50 75? So 50 75 is there. So uh, 50 is 70, it is there, just wait. 50 60 60 will be there, more there. Okay, so that's purpose, just wait. Yeah, is a 60. Okay, and is a 50 50 75. So here is a 50 and here from 70 and 75 is there, there is approximately. Okay, so remaining point will be draw later on because it is difficult to draw. So here, what we observe that here is a straight line from here, just wait. Is it? So there is a straight line from here, is it? So that will be straight line from here approximately. Okay, okay, there is a straight line means what will straight line indicate that, yes, the speed of the car. Okay, yes, then object in uniform motions cover equal distance in equal interval. This graph is distance time is straight line, is it? So this straight line indicate that is the uniform motions. Any graph, any time distance graph will be straight line, that is a uniform motion. Okay, or uniform speed, that will be graph. Okay, so remaining point you can draw and tell me that it is a line is straight line or not. Okay, yes, an object in uniform motion covers equal distance in equal intervals, thus graph between this is a straight line. You already draw this graph. Is it in the distant time graph above, what does the slope of the straight line indicate? So a straight line indicate the speed of the car. Is it what? Speed of the car. A straight line indicate that the speed of the car means how much distance cover in how much interval of times. This indicate that what? In the distant time graph above show that the speed of the car. Okay, straight line indicates speed of the car. So how to calculate speed of the car? Final yes, so final minus initial upon final minus initial time is the speed of the car will be calculated according to that. Okay, so next, distant time graph for non-uniform motion. You previously already studied about the uniform motion. Uniform motion is a straight line, and straight line indicates that the speed of the car. So here is a given the different example. Here is the example given that the bus. Okay, the following table show the distance covered by the bus in equal time interval. Draw the graph distance against time, taking the time in x-axis and distance in y-axis. In figure 1.6, thus the graph is directly proportional between the time distance. Okay, so here is the in this graph here is the time x-axis. So you can draw the here time. What is here is the first of all is the 5. Here is the 10. Okay, just wait. I'll take small one. Okay. So, okay, small one. Okay, fine. Here is the 5. Here is the 10. Here is the 15. Okay, according to you can draw the here is the in the range of 5. Okay, and here is the distance. So what will be distance here cover in this? So here is the first of all you write here 10, 20, 30, 40. Okay, like that you can draw here from here. Okay, so what will you observe? Speed is 0, time will be also 0. Okay, next is time is a 5 and speed will be 7 meters, is it? So 7 meter approximately here. For where is the near? Just wait, I will be zoom in. Oh, not possible zoom. Okay, fine. So approximately here, so below 10th, here is the speed, is it correct? Okay, here is the speed. After that is what? A 10 is a 12. Okay, here the go to the 10. If it is a 10 or here is only what? 10, 12. 12 means about 10, is it? After that is 15 is a 20. So here is a 15. Here is a 15 and here is a 20. Okay. After that is a 20. Here is a 30. Okay. Here is a 30. After that is a 25 is a 41. 41 like this. So how will you observe that is if you draw the line graph here, so will be observe that like this. Okay, it's not a straight line graph, is it? So not uniform motion is not a straight line graph in simple word. Here the distance change non-uniform with the time, thus the bus having a non-uniform motion means here the time will be changed. Here the difference of time is 5, 5, 5, 5, 5, 5, is it correct? And that, and here the difference of distance will be what check. Here is the 7, here is the 5, here is the 8, here is the 10, here is the 11, here is the 9, here is the 8, means here the different will be distance will be difference is different. Okay, so here is the non-uniform motion means distance and equal interval of time distance will be called different is called non-uniform motion. Understood that? Yes. So what difference do you see in the distance time graph for uniform and non-uniform motion. So that will be homework for you. You can tell me that. So what difference do you see in the distance time graph for uniform and non-uniform motion? Okay, you can tell me that. Okay, fine. Yes.